One of the models for knowledge that I'm looking at right now is one that comes out of the knowledge management industry, really. And that's what, well, I keep thinking it was a DKNY model, but that's not right. It's the DIKW model: data, information, knowledge, wisdom, which is often called the DIKY hierarchy, which is something I'll maybe come back to. And what the DIKW model suggests, or it just gives you a way to think about it, really. It's not a grounded scientific theory or anything like that, although it does structure itself quite well metaphorically, I think. But how it works basically is it conceives of knowledge in the broadest sense as being part of a hierarchy or a continuum or a chain of entities or concepts, which at the one end consists of data, which are kind of raw, atomistic, elemental entities, unstructured, unconnected, disorganized, existing as kind of potential. So, for example, these might be rainfall figures or scores on a particular chart or something like that, unconnected to each other. And those data, when we think about those data, they're kind of understood as a resource that we can mine. So we talk about data mining, or that that can be somehow stored, or that can be collected. So the data pre-exists our approach to it, rather like a natural resource in the world pre-exists our approach, our exploratory processes of finding it. Data is also conceived of as what? Well, it's kind of atomistic. It can't be divided. There's nothing in terms of whatever analysis you're carrying out. Each individual data item can't be broken down, or not sensibly, without changing the whole parameters of your analysis. So a particular rainfall figure on a particular day is just that figure. It doesn't make any sense to divide it into smaller parts, any more than if you're collecting fossils. It doesn't make any sense to separate one bone from another and consider them two fossils, not without damaging the data. So, and that data also is conceived of as, well, I think in terms of substance it has an odd sort of quality. It's partly conceived of as kind of granular, or kind of, well, I'll just say atomistic. There's these small little elements or nuggets of knowledge, information, whatever you want to call it. But it's also, it does also kind of flow or fall apart from each other. So data can be lost, or data can be hard to handle. And I think that's because of this sort of granular quality. I'm conceiving it kind of like sugar or salt. Salt is better because I'm near the salt line. So data is kind of like grains of salt, which are disaggregated very easily. They can be contained, but they don't have any sort of natural relationship to natural structure between themselves. Okay, so that's data. This is the little tiny elements, indivisible, probably quite hard, but they act kind of like a liquid, sort of. They do flow, but only in the way that granulated solids flow. Okay. Information, slightly different. It is a part of a continuum, so these metaphors inevitably overlap. information is, well, certainly in the DIKW literature, information is the point at which data becomes meaning. So it starts to acquire structure, and different data can be assembled in different ways and are formed in different ways, hence information. And how it's formed affects what it means. So rainfall data, for example, can be assembled into a graph. For example, you can take the elements and that'll give you a curve which shows you rainfall over a particular period of time, and that's information. Or the location of certain fossils in rock strata can be